Alright, so now that we've been through our introduction to what the standard normal distribution looks like, we should take a closer look at what do we do with it. So let's first quickly review that. Remember, our standard normal distribution, the standard tells me I have a mean, median, and mode of 0, and then a standard deviation of 1. So I have 1, 2, 3 standard deviations on the right that were positive, -1, -2, -3 on the left. 68% roughly is in the first standard deviation. About 95% of the information will be in the second, and then 99.74 in the third. So it just tells me how the information is distributed. All right. So where did this come from? This came because it's also called the Gaussian distribution. So this came from Carl Friedrich Gauss. He's a very important mathematician. You can see back from 1777 to 1855, he was alive. My favorite way to describe Gauss is something I read one time that said, if math was a football team, Gauss would be the quarterback. You know, the quarterback's a really important part of a football team, and Gauss is a very important part of mathematics. So everything he did in math really was pivotal and changed what happened after it. So here's Gauss's contribution to the standard normal distribution, as he created this function that models what will happen. So to figure out how much area is to, he will do to the left of our standard deviation that we give you. So you can see this crazy function, but don't worry about it. We're going to replace that function with these charts. So I'm going to have two charts, one for positive numbers, one for negative numbers, but it uses that function that I just showed you, and it tells you what percent of the area is to the left of whatever number I give you. All right, so here's what we're looking at. When I see this chart, we're looking at what is on the left. So see this little curve up here and where it draws a line? Z indicates what number we're looking at. So it may not always be 1, 2, 3. It could be 1.25 or 1.74. So we can be pretty precise in how far away we want to be from the mean. But it's important to know that every time we use the chart, it will always tell us what's going on the left. Because 0 is in the middle, so see here I 0 in the middle, I know I have half to the right, half to the left. Just to show you that half to the left, see if I have 0, and if I were to draw that line in and look at what's to the left, see here it says 0, it says 0.5. So we have that symmetry in there. Okay. So when we're looking at this data, we are going to call the number we're looking at Z, and whatever number I give you, unless I indicate otherwise, we're looking at what goes on the left. So let's say I started with Z is 1.6, and I want to know what percent of the data is to the left of 1.6. All right, so I zoomed in on that chart a little better so you can see it, and if you look at the arrow, it's 0.9452. That says, if I have this chart, 94.52% of the data is to the left of 1.6. Let me draw for you, even though I'm not a great drawer, what this looks like. So here's my bell-shaped curve. I'm not very bell when I draw it, but that's okay. So say this is 0, and then this is 1. About here, 1.6, and I'm going to call that 1.6. If I looked at what's to the left, and what's the area under the curve, it would say I have 94.52% of the data is to the left of this number I gave you. So let's try it again. This time I said let's use Z is 0.23 because I want to show you numbers on the vertical and along the top. So here's 0.2, and then when I go over to 3, this makes 0.23, and it says 0.5910. So that's 59.10% of the data is to the left of 0.23. Again, if you want to draw it, if you can get through my drawings, here's my curve again, here's my 0, and then just a little bit over I would have 0.23. And then I would draw up, and this says that area that we just found in the chart, which is roughly what I just drew, is 59.10%. Right. So let's try again just to get more practice with the chart. Let's say I picked Z as 0.85. So I look on my chart, 0.8 on the left, and then I go over. So I kind of follow along, and there's my 0.05. So 0.85 is 0.8023, which says 80.23% is to the left of my Z. Okay. So just to make sure we see that there are two charts, and we use both of them, these numbers have negatives. So you can see right here, I said, what if I say left of negative 2.43? Nothing different happens when I use negatives, except I have a different chart to look at. So here's negative 2.4, and then I go over to 3, and it says 0.0075. So it's a very small amount of the information to the left of negative 2.43. If I can draw you just quickly, again, I'd like you to kind of visualize what's going on. So this is 0. Say this is negative 1. This is negative 2. So here we are at negative 2.43, and I'm looking to the left. We call this a tail region. It's just this really small little piece in the tail. And that's why it's so little, is because it's so far away from my mean, median, mode, which were 0. Okay. Pick another number. I'm getting a little closer. I'm going down around here to negative 2.04. And I'm looking again on the chart. You can see I underlined it. Negative 2.04 says 0.0207, or if you want to say 2.07%. You do notice I'm flipping back and forth between decimals and percentages. Again, like we did in probability, I think everyone's mind wraps around percentages better, so I like to talk about them when we go through these lessons. So I want you to try, and I picked all positive ones here so you can use the chart that's just up on the screen for you. Pause the video for a minute. Try to do these 3. They're all looking what areas to the left of the 3 values I gave you. After you've written them down, take the numbers from the chart, come back, and let's see how you did. Okay. So here are the answers. The first one, 1.44. So here's 1.4. And then I have to go all the way across to the other 4, and it says 0.9251. The second one I gave you is 0.92. So here's 0.9. And a lot of times if I'm having a hard time lining up, I'll say 0.9, then I count 0, 1, 2. You want to make sure you remember that first category is 0, then 1, then 2. So I got 0.8212. And then the last one, 1.71, here's 1.701, there's 0.9564. Okay. So what if I wanted to know the area to the right of the z-score? Well, it's important to remember that our entire curve is equal to 1, so everything under the curve is equal to 1. To get the area on the right, so if I'm looking for this over here, I'm just going to subtract from 1. So let's make this a little more clear with an example. Okay. So let's say I want to find the area to the right of z is negative 2.41. Right? So this time I'm going to the right. Okay. Well, we know the area to the left of negative 2.41 because we can look at it on our chart. Here's negative 2.4, so the 1 is 0.008. To get the area to the right, I'm just going to subtract. So I do 1 minus 0.008, which gives me 0.992. And down here, I drew you the picture, so this one is down here to say if this is negative 2.41 and the chart gives me this, which was my 0.008, the rest of it, if these two together are going to add up to 1, I do 1 minus the 0.008, there's my 0.992. Okay, so let's try it again. Let's try to find the area to the right of this time negative 2.19. So here's negative 2.1, and then I go all the way over to get to the 9, and it gives me 0.0143. Every time I go to the right, I'm always subtracting from 1. So 1 minus 0.0143 gives me 0.9857. All right, again, I want you to try. So here's 3 values. I went back to the positive chart again, just so we mix that back and forth, but I want you to try these 3. All going to the right, and then come back and check your answers. Okay, so here's what I got. I start with 1.63, so here's 0, 1, 2, 3. My area to the left was 0.9484, so 1 minus 0.9484 gave me 0.0516. If I go to the right of 0.71, so here I'm at 0.7, there's 0.71, I have 0.7611, so 1 minus 0.7611, but make sure you're using your calculator to get these. I don't want you guys wasting time doing it by hand. I got 0.2389. one more of these and we'll try something else. I have the 0.22 that I want to look to the right of. So here's 0.2012. I have 0.5871. Again, 1 minus. So 1 minus 0.5871 gives me 0.4129. Alright, so hopefully you guys are getting the hang of this. On the left, I just use the chart. On the right, I use the chart, but I do 1 minus whatever it says. Okay, so how about if I give you 2 z-scores? I'm trying to find the area in between. So not just 1 z, I give you 2. So this one, I gave you 1.7, and I gave you 0.6. So I tried to draw it on this little chart for you to say if this is my z-score, and this indicates 0, 0.6 would be pretty close to there, and then 1.7 would be farther away. But when I use the chart, if I go to 1.7, it tells me everything all the way over, right? I would keep going this way. It would give me everything to the left. And if I look at 0.6, 0.6 tells me from here all the way over, okay? So, and maybe if I switch colors, I guess it's, there it is. It'll let me do that. To say this yellow one, I'm going to kind of squiggle it, was everything I got from 1.7. And then this red one is everything I get from 0.6. So to find this kind of hash mark in the middle, I'm just going to subtract. So I'm going to look at both of those areas. And here they are over here. At 1.7, I can see is 0.9554. 0.6 is 0.7257. To get the area in between, I simply subtract them. Don't worry about how do I know which ones go first. The big one goes first. So anytime I subtract, it's the big number minus the small number gives you your answer. So the area between those two is 0.2297. All right, so let's try again. Let's go between 1.41 and 0.54. So 1.41 right here is 0.9207. 0.54, a little bit farther up on our chart, gave me 0.7054. As always, put the big number first, 9207, subtract 7054, I get 0.2153. Okay, you try. Here's back to the negative chart, so I'm flipping back and forth with positive and negative, but I gave you 2 z-scores. I want you to try to find the area in between. So here is the answer. When I look at negative 2.01, I got 0.0222. And when I look at negative 2.51, up here, I got 0.0060. Okay, so I put the bigger one first, which is this 2222, minus the 0.006, and I got 0.0162.